right, so I guess first off, why Kafka Streams and why me? Start with a little bit about me and why I want to talk about Kafka Streams. So first off, if you just came for the Otters and don't know anything about Kafka Streams, basically it's a stream processing library. It's part of the Apache Kafka project. It's super simple and easy to use. There's no cluster. There's no submitting jobs. It just runs in your environment. So whether that's production Kubernetes cluster or just your local laptop, you just write up your application and deploy it against Kafka, and that's Kafka Streams. It has a nice API. So, for example, there's a high-level DSL which kind of provides operators for all kinds of processing logic. So simple things like filters and maps, all the way up to more complicated database stateful operations like aggregations and joins. Okay, and now quickly just, why me? Why should you listen to me ramble about Kafka Streams and Otters? I've been working on Kafka Streams for about 5 years, so I've committed a lot of code. I'm a committer and a PMC member for Apache Kafka, which means I've also reviewed a lot of code and the KIPs that go along with it. And right now I work at Responsive, so just briefly, Responsive is managed platform for Kafka Streams. We separate storage from compute, provide auto-scaling, all the things you need to run your Kafka Streams apps reliably and at scale. And I'm a Kafka Streams fan, so that's kind of why I want to talk about it. And I spend a lot of time with it. I get to see all the cool things that happen, and I just want to share a little bit of that with you guys. So, why Kafka Streams, and then also you're probably asking why Otters. You might have noticed there's a theme here. Just to connect the dots a little bit, Otters are the unofficial mascot of Kafka Streams, and I think by the end of this talk, hopefully you'll understand why that is. So basically this is the format of this talk. We're going to learn some Otter facts, and we're going to learn some Kafka Streams facts, and like I said, you'll understand why they're connected. So we'll start with something nice and simple. Otters, they're fast, lean animals that live in large groups, and Kafka Streams is a fast, lean application framework supported by a large community. Nice and simple. All right, here's our next Otter fact. Baby otters are called pups. They're very cute, obviously, and they can be born any time of the year. With Kafka Streams, baby features, we call them KIPs, and we ship them all throughout the year. So first off, if you don't know what a KIP is, that's pretty fundamental to this talk. So basically it stands for Kafka Improvement Proposal. It's the process for shipping new features and major changes in Apache Kafka. It's where we argue about minor details and also some important things. But all of these KIPs that we ship, they represent some new feature, something useful, we hope, some major change, and a lot of work goes into them. So just some quick, fast facts for Kafka Streams specifically. We have about 191 shipped KIPs for Kafka Streams. That's out of all Apache Kafka. Since I last computed, the number might have even changed since then. We average about 8 KIPs per release, with the highest number being 14, which is kind of crazy to think about 14 KIPs in one release. But they're being shipped all throughout the year and in every release. All right, so next Otter fact. Otters are semi-aquatic animals whose bodies have specific adaptations for moving and balancing on both land and water. Whereas Kafka Streams can have stateful and stateless tasks, and it also has adaptations to optimize balancing and assigning tasks. So we're going to start our shallow dives into KIPs with a subject that's near and dear to my heart, which is task assignment. Before we jump into the KIPs themselves, we'll just do a quick overview of what the hell that means and why it's so important. All right, so task assignment is essentially linked to the consumer group rebalancing protocol. In a Kafka Streams application, each stream thread, which is just the kind of fundamental worker unit, each stream thread is a consumer, and the tasks correspond to Kafka topic partitions. So the tasks are the fundamental unit of work. So whenever you have a change in the group, like you scale in or out, you have clients that are joining or leaving, that triggers a rebalance. And the point of a rebalance is to balance those tasks across the new members of the group, or the new set of group members. So it's a little bit more straightforward in plain consumer apps. It's a little trickier in Kafka Streams due to quite a number of things, but one of those being the presence of state. So due to stateful tasks, there's a lot of different factors that go into picking an ideal task assignment for Kafka Streams, and we'll see just a preview of those. But there's a million different things that the assigner is doing. But why stateful tasks in particular are such a challenge? Basically, if you ever reassign a task to a new node or a node that didn't have a copy of that task before, basically you'll have to restore all the data from the change log from scratch. Which the important thing to know about is that just means a long delay before you can get that task up and running again. So one of the ways that Kafka Streams deals with this is what we call standby tasks. So there's the active task, which is basically the one actually doing the processing from the input topics. And then there's the standby tasks, which are just additional copies of an active task. And they only maintain state, but they don't do any processing. So task assignment, it's complicated, but that also means there's a lot of opportunities for improvements based on just the assignment alone. And that's what we'll take a look at with some of these KIPs. So first up, we actually have two different kinds of rack awareness, two different rack awareness KIPs that we're going to look at. So the first one is focused on availability and kind of resilience, specifically around stateful tasks and standbys. Like I said, restoring from a change log is slow and it's painful, and you don't want to be on call and get pinged for that because it's taking hours to restore. So you want to make sure you always have a copy of that state standing by somewhere. So if the active task goes down or something happens, you can kind of easily reassign the task and keep running without having to restore from scratch. Of course, that means you have kind of a coupled failure, like an entire rack goes out, for example, and that takes out every copy of a stateful task, like the active task and all the standbys, then you're going to have a bad time. So the goal of this KIP is really just to minimize the risk by making sure that you spread your standby tasks out across your environment, whatever that setup looks like. It's pretty simple. You can configure tags to define how those tasks do get spread out. So for example, you can set a rack ID, but you can also define custom tags for anything really. So you can have tags for things like the data center, and basically it just tells Kafka Streams to move all those tasks so that one outage in one place doesn't completely destroy all your copies of a particular task. So that is KIP 708. That's our first type of rack awareness, and that is an already shipped KIP, so you can use that today if you upgrade your apps. All right, so the second kind of rack awareness is kind of more general rack awareness. It's completely different from the other kind of rack awareness. Basically, the goal here is just to reduce costs. What it essentially tells Kafka Streams to do is try to place these particular tasks on a node that is within the same AZ as the broker that it's going to be reading from. So as opposed to the availability and resilience of the other rack awareness, this one is really just about reducing costs. And again, it's easy to use. You just configure the rack ID for your clients, and the assigner will figure out the placement and the rack ID for your brokers as well. And that one has also been shipped. All right. So the last task assignment related KIP I want to talk about is KIP 924. Again, also shipped in, I want to say 3.8, so pretty recent, this one. But basically, it's, as it says, you can now basically completely customize the task assignment logic for Kafka Streams. So one of the things that lets you do is you can plug in like an alternative to the default assignment strategy. For example, there's an out-of-the-box task assigner called the sticky task assigner that Kafka Streams has, and for a while, basically only the default assignment strategy was available. It's something called the high availability task assigner. It's kind of a mouthful, and also it doesn't work that great in all situations. So it's nice to be able to switch to a different assigner if you have different needs, if you want to optimize for something different, like balancing the tasks or kind of having a more stable task assignment rather than trying to make sure that every single task is kind of up and available. Of course, if you're feeling adventurous, you can also write a task assigner yourself. I'll admit, writing an assigner is not trivial, but luckily this kit comes with a set of utilities. Basically, it like modularizes the many complicated steps the default assigner has. So you only have to rewrite the parts of the assignment that you actually want to change, and then you can just call on these utility methods to do all the other stuff that you don't really want to muck around with. For example, like the 2 rack-aware optimizations that we just talked about, they're available for you to just apply on top of your custom assignment logic, so you don't have to, re-implement like this crazy graph and this crazy graph algorithm from scratch yourself, which is pretty nice. All right, that is task assignment. Move on to another Otter fact. This is actually, one of my favorites. You can probably tell why. Basically, it said otters have a little poop dance that they do when it's time to go. And they even have a dedicated latrine area. And there's a video to prove it. I assume that's what they say it is, but you'll have to take the internet's word on that. I'm sure you're wondering how I'm going to connect that to Kafka Streams, but here we go. Kafka Streams. Kafka Streams has an exception handler. It invokes when errors occur, and it even has a dead letter queue to quarantine any shitty records. So those are our next 2 KIPs. We're going to be chatting about error handling. The first one is KIP 1033. This one is recent. It's coming out in 3.9, which I think will ship soon, whatever that means. It's being released as we speak, I guess. Basically, this is something that, frankly, we should have had a long time ago in Kafka Streams, but didn't. Basically, it adds an exception handler so that if something happens during your processing, your actual processing logic, like your aggregation or your join or your custom processor, whatever that is, if an error happens, you can catch it and handle it however you like, rather than what Kafka Streams does today, which is just crash and die. Not ideal. So this actually kind of works out nicely with the second error handling KIP, which is the dead letter queue. So another thing that honestly we should have had a long time ago is support for dead letter queues. It's a super common pattern. Pretty much everyone that runs production Kafka Streams apps probably has implemented some form of this. If you're not familiar with the term, it basically means if you come across a record that there's an issue with it, you can't deserialize it, there's a production error, you can't send it to the output topic, or now if you hit a processing exception, instead of either having streams just crash or continuing onwards and potentially losing that record, you can just send it to this dead letter queue, and then obviously you can consume that on your own time, either with another Kafka Streams app or consumer, whatever, that kind of just puts everything in one place so you can kind of visit the issue later. It's super nice. That one is in voting. I think I need to remind myself to vote on it, but that will be coming soon as well. All right, next Otter fact. So it's kind of a simple one. There's different kinds of otters, river otters and sea otters. Little fun fact, the Kafka Streams mascot is a river otter, but it's a little generic, so it could really be either. But, all right, Kafka Streams has this DSL, like I mentioned. Defines operators for your processing logic, and there's 2 types of operators. They're stateful and stateless. we talked about in the context of tasks. All right, so next Otter fact related. Digging down into the different otter species now, there's actually exactly 13 different river otter species and 3 different sea otter species. What about Kafka Streams? Kafka Streams, this is true, has exactly 13 stateless DSL operators, and it only has 2 different stateful DSL operators. So that fact actually doesn't match up. That's not quite right. Just in case you don't believe me, here's a list. I'm not going to go through it all, but there really are exactly 13 river otter species and 13 stateless operators. But sadly, we only got the 2 stateful operators. Of course, aggregations, there's a few different versions of it, but there's really just the aggregations and the joins. So here's our 3rd stateful operator. We have to match the otters, of course. Well, we have a new stable operator coming. Thank God. This is coming here to save our otter fact. We have the deduplicate operator. This actually comes from KIP 655, which, for reference, the KIP number now is in the thousands. So this was started like a long time ago. It hasn't been going on this whole time. That would be kind of sad. But sometimes people start KIPs and for whatever reason they can't or don't want to finish them. And then, as in this case, somebody else came along and they wanted to pick it up and finish it. And so that's what they're doing. It's nice to finally get some progress on the deduplicate operator. I will say there's a lot of users that basically they only venture into the low-level API, the low-level processor API, just to implement basically a deduplicate operator. So it seems like something that kind of makes sense to just offer out of the box in the DSL, especially because it's pretty critical to get it right, especially if you're like producing billing events or something. You don't want your customers to pay twice. I mean, maybe you do, but they probably don't want that. So that's where deduplicate comes in. And yeah, right now we're working out the semantics for this deduplicator, as well as what kind of interface to provide. So like do you want to deduplicate based only on key, kind of like Kafka topic compaction? Maybe you want to deduplicate based on the value, or even operate on like a subfield of the key or value. There's a few options there, and this KIP is actually in discussion right now. So if this seems interesting or useful, I encourage you to join in the KIP discussion, and please give us feedback as an actual user. Or you don't have to be a user, but it would be great if you were. Okay, on to our next otter fact. So river otters, they apparently communicate with whistles, yelps, growls, and screams. Streams, on the other hand, just communicates with RPCs. And honestly, there's not even any Kafka Streams specific RPCs. It really just uses the consumer and the producer clients, and those guys communicate with the broker, with the group coordinator, using these RPCs. So no Kafka Streams specific one, at least for now. Basically, one of the biggest improvements in recent Apache Kafka history is now coming to Kafka Streams. Some of you, you may have been to one of the multiple talks on this thing that we call next-gen rebalancing. It's basically a major overhaul of the rebalancing protocol. This was a KIP 848. It was like a long-term project. Probably anyone who has had to operate a Streams app will be familiar with rebalances. Probably too familiar. Frequent or endless cycles of rebalancing has basically plagued users since day one of Kafka and consumer groups. Now we have made a lot of improvements over the years, like cooperative rebalancing and static membership, but the fact of the matter is rebalancing has just been a persistent issue, and it's something that a lot of people grapple with in terms of like operating their Kafka Streams applications. So a little while ago, I don't know, it's got to be a year or more at least. Basically, some of the Kafka devs, not the Kafka Streams ones, they sat down and they designed an entirely new rebalancing protocol, which is what we call the next-gen rebalancing. And so, KIP 848, it was merged and shipped a little while ago, and of course, it brought a golden age of rebalancing in Kafka. for consumer apps, that is. But what about Kafka Streams? So KIP 848 only works for the plain consumer apps. Basically, it introduces this concept of a consumer group, which, of course, already existed in a literal sense, but now it is a group type called consumer. But there's no Kafka Streams group, and Kafka Streams hasn't been integrated with the new rebalancing protocol just yet. Well, just yet. So it's not actually available yet, but we have a plan, and we're going in a slightly different direction. We have now KIP 1071, which we're currently discussing and arguing over and debating endlessly. Basically, instead of kind of integrating the new consumer group rebalancing protocol into Kafka Streams, we are going to take the opportunity to introduce an actual streams group type. So this means, Kafka Streams will have specific RPCs that it uses to communicate with the brokers, with the group coordinator, and, something that's separate from the plain consumer group. Which is great. So, basically, we're going to get all of the benefits of KIP 848. So, for example, there's no more group-wide synchronized rebalances. I would refer you to the KIP 848 talk to get more details on this. Like I said, these are shallow dives. But essentially, instead of having all of the members of the group kind of do a synchronized wait and join the group and then wait for their assignment and then process it, the group coordinator can kind of reconcile the assignment sort of one-on-one with the clients. So it removes a lot of the issues that kind of came along with these big group-wide synchronizations. There's some issues in Kafka Streams, especially about like follow-up rebalances being triggered and other members of the group kind of struggling to rejoin in time. Basically, it's a long-standing issue that is finally being addressed, and that's pretty nice, I think. Now it's, I guess there's the obvious question of like, why not just integrate with KIP 848? Why did we create a whole like streams group concept? And well, basically it's a good opportunity to kind of start, lay the groundwork for some optimizations and future improvements for Kafka Streams by having a group coordinator that actually understands Kafka Streams and can differentiate it from a consumer group app. So, for example, in the current rebalancing protocol, there's no concept of a task. It's all just topics and partitions. But Kafka Streams, of course, has tasks, and it has active tasks and standby tasks. It has all these different kinds of tasks, and it has a bunch of metadata that it uses to perform the assignment, like the offset sums for stateful tasks. There's a bunch of stuff going on, but the broker doesn't really know anything about that right now. So with the Streams group, the broker, with these new RPCs specific to Kafka Streams, the broker can now understand these stream-specific concepts, like tasks and the different kinds of tasks, which is nice. So that means a few things. For right away, it means no more pesky follow-up rebalances. So things like cooperative rebalancing or probing rebalances. There's a lot of different reasons that Kafka Streams will have to basically trigger another rebalance after one just happened, and that can contribute to the general instability of the group. So nice thing about this new rebalancing protocol is we don't need to do any of those things. There's no cooperative rebalances because, well, it's a long story, but because there's because the group coordinator can kind of interact and reconcile the assignment with each individual client, and there's no need for these probing rebalances, which are essentially probing to figure out if a task is finished warming up, like restoring from the changelog, because now the group coordinator can understand the task, it can understand the offset sums, and it can figure out when something is actually finished restoring and then move it without going through a rebalance, and without doing the probing rebalances, which probe every 10 minutes. So basically, that's KIP 1071. There's a lot of cool things just right out of the box, but it also lays the groundwork for a bright future of Kafka Streams as first-class citizen in the Kafka world. No more being limited, no more fitting an Otter-shaped framework into a generic consumer-shaped box. And we're still discussing it. If you want to get involved in that discussion, be my guest. It's a lot, but be prepared to argue in a good way. All right, next Otter fact. Okay, so this is fun. Though most otters are pretty small, turns out when they work together in a group, they can take down much larger animals, like crocodiles and even jaguars, as you can see in this fun little video of a bunch of otters. I don't know if they're taking down the jaguar, but they're certainly managing to keep up with it. All right, so, oh, look at them go, so cute. Streamed fact. Okay, so sometimes there's only so much a single stream thread can do, but if you have a pool of threads working together, then they can take down even large backlogs or input traffic spikes. The crocodiles and the jaguars of Kafka Streams world. I think they're taking down a crocodile in this video. It's hard to tell. So anyways, that's just my fun little way of introducing something that I like to call async processing for Kafka Streams. Just to clarify up front, there's no current KIP for this. There's no concrete timeline for when we'll have one. We know it's something that we'd like to have in Kafka Streams, and I think it's exciting to talk about, and so you guys have to listen to me. Basically, while Kafka Streams it's flexible, it's able to scale elastically. Its parallelism is ultimately limited by the number of partitions that are in the source topics, but it doesn't have to be. Ultimately, the partitioning of the source topics is pretty much arbitrary, and what really matters is just that you process records with the same key in order, in sync. But when it comes to different keyed records in the same topic, they can really be processed in parallel. They can be processed asynchronously, and that's what async processing is. So we actually implemented something like this at Responsive. Right now it's just a wrapper around Kafka Streams, but we do plan to contribute the feature in whatever form back to open source Kafka. But the essential feature is just you have a thread pool of these async workers, and so the stream thread that normally processes the records from the partition in order, it can just kind of trigger the async framework to process and maybe wait on some of these records with the different keys, especially if you have RPCs or long processing like remote state store calls. Those can the latency for those operations will build up if you process everything in sync. But if you can kind of farm that off to an async thread pool, then you don't have to be stuck blocking and waiting for an RPC to return or a read to a remote state store to get back to you. And yeah, that's async processing. Status, waiting for a KIP, we'll figure it out. It's a matter of when, not if. All right, so let's wrap things up here. Here's our second to last Otter fact, actually. Now, otters are considered apex predators. Kind of surprising, you wouldn't think that, but they're at the top of the food chain in the nearshore environment, at least. What about Kafka Streams? Well, as an objective fact, I would say Kafka Streams is an Apex library, and it is at the top of the food chain for stream processing applications. Okay, that's it for it's our KIP roundup. Now we'll leave with some takeaways here. First of all, otters and Kafka Streams, they go together like otters and actual streams. Hope I've made that point. Second, we accept KIPs. So if you have an idea for a new feature, if you have something that you want to see in Kafka Streams and you want to implement it yourself, just go ahead and write up a KIP and kick it off for discussion. Anyone can do it. You can do it on your own. You can also always reach out to me or any of the other Kafka Streams devs, and we're happy to guide you through the process. And if you want to see a new feature but you don't really want to implement it yourself, you can always just file a Jira ticket and maybe somebody else will pick up the KIP for you. It's the beauty of open source. All right. join the KIP discussions. Please, we would love to hear your feedback on new features. We would especially love to hear from you during the discussion and design phase of a feature and not after it's already been shipped and then we find out that it doesn't do what people wanted or expected. So, join the KIP discussions. Give us feedback. That's it. You can subscribe to the dev mailing list and just look out for anything with the subject line that's like discuss and then a KIP number. I will warn you, you probably want to set up a filter for everything else because there's quite a bit of junk, depending on your perspective, that you'll get from this mailing list. But, easy to set up a filter and easy to join the KIP discussions. Please do it. One more thing to plead about, please upgrade your Streams applications. Please, please, please do that. You're missing, if you don't do that, you're missing out on all these cool new features. You're probably missing out on some critical bug fixes. There's improvements that go in, there's people are doing all this work, and it just goes to waste if you don't upgrade your Streams applications. So I'll ask you now, I'll ask you, probably the first thing I'll ask you if you have a problem and you ask me for help with debugging it, the answer is gonna be to upgrade your app. All right. That's the end. So I'll leave you with one final fun fact. Did you know that otters like to juggle rocks? And again, here's a video as proof.